MSL is a measurement institute, National Measurement Institute, and we have the most accurate measurements of power that are possible in New Zealand at the moment. And so it's important that we have the best accuracy so we can calibrate instruments and ensure they can be trusted for doing measurements all around New Zealand. So we support the test houses who calibrate meters for industry and domestic use, and we make sure the measurements are reliable. That's really what we do. Obviously, it's a massive business, a lot of money in effect going through those wires, and it's really important that the measurements of electricity are accurate and reliable and trustworthy, because it's a big economic market, and so the public and the users have to have confidence that when they get their power bill, that it's based on reliable measurements. The whole system is becoming increasingly complicated because of these various sources of ways of generating electricity, making a lot of what we call distortion or harmonics into the grid, and sort of the more traditional metering doesn't really deal with that very well, so we're looking at ways of measuring that ourselves, higher frequency measurements, and also there's an increasing demand for accuracy as well at the same time. So, certainly for power, it's the consumed power, but there's also power that can potentially go both ways, and the phase relationship. So it is a complicated set of measurements that's needed, and increasingly is interest in associating time with power as well to make sure it's understood where the power is being used and so on. So absolutely. Certainly time stamping of measurements is really important. There's kind of a technology developing what we've got around phaser measurement units where you can measure the various vectors at any instant in time. And people around the world are looking at that as a way of controlling some of the grid stability issues that are a real challenge for the grid operators. And so linking accurate timing with accurate measurements is becoming perhaps a requirement of the future. Okay. Obviously in the grid you've got all the voltage is constantly varying, the current is constantly varying, and just keeping track of where they are in their phase relationship and then their amplitude is a valuable tool to figure out what's actually happening around the grid and where the power is flowing, and where there's perhaps indications of instability is about to appear. And so a number of countries are installing these phaser measurement units to try and help them deal with that grid stability problem. So you really need to both accurately measure the voltage, the current, and the phase, but also at the time and know where the vector is at any instant in time. So certainly their reference gear, which they base all their measurements on, needs to be modern and well maintained, calibrated, and they need to understand the accuracy of those reference meters. And also they would also consider the higher frequency distortions that may be coming through, how to accurately measure those. So more sophisticated measurement equipment is kind of being needed. I think that puts demands on the staff to understand how these instruments work and how to properly maintain them. And so there's real need for training and understanding and really what is quite a sophisticated measurement system.